Okay, we'll start Scala part today. So Scala we're learning for Spark. We can do some job on MapReduce also. We can write code in Hive UDF, Big UDF, any user-defined functions. So Scala is very useful. Okay, many places wherever you're using Java, you can actually apply Scala. And nowadays, whatever framework is designed for big data, they're using mostly Scala compared to Java and other languages. That is also one reason to uh, get more weightage in industry, and according to that weightage, more openings, obviously. Now, when Scala came, what is Scala history? Why? What is the difference between Scala and Java? What is the difference between Scala and Python? Those things we'll cover first. We'll see concept. Not I'm going to derive the complete theory. One book is there with me of cookbook. I'll share that book to you guys. Whichever is more theoretical, I'll tell you that you can go to that page and read the topic. But concept, architecture, and practicals, these three things will be doing here. Starting with the Scala. Now, Scala journey, if you ask me, this is started from 2001. So 2001, we get to know first what is a Scala, and the founder of Scala is a founder of Java C also, the person who started working with Java compiler, right? He's the same person. That name is a Martin Oderisky. So he's the founder of Scala. Now, Scala term we get from Scala word we have collected from scalable term. Okay, this Scala came from the actual word scalable. Since this is concise, elegant, we can scale it up to any cluster, to any level. We call this is a scalable language. We'll compare, so you'll know in how many lines I need to write in Java, how many lines I need to write in Scala. Both that comparison you'll find. So few things we know. Scala is there since 2001. Person is Martin Oderisky. It is a scalable language. Okay, now Scala was supporting .NET platform and Java platform till 2012, and after 2012 they stopped supporting .NET. They only support Java platform, okay, as an JVM platform, not any other platform. So Scala also typically follows the concept of compiler, then interpreter, right, like runtime. Now I will first compare this Scala with object-oriented programming. Okay, let's say Java. So point number one, compare Scala with object-oriented programming. When I say object-oriented programming, C++, Java, both can come. Especially Java, if I speak. In Scala, there are so many optional statements now. Okay, as an first point, Scala is more concise, elegant, and easy to read and write. Easy to read and write. In Scala, so in Scala, one line of code, is 10 line of code in Java. Okay, so I think this is the ratio. One line you're writing in Scala to achieve the same output. There in Java, you're writing 10 different lines to get the same output. So obviously I can say this is more concise, less line of code I'm writing. My interpreter will also take less time to compile and run those programs, so it will be faster anyway. They have autocomplete option. Uh, Scala has autocomplete option. So autocomplete means you're not writing everything by your code. Scala workspace, which will be IntelliJ for us, and we already have installed and seen this. This is the Scala workspace for us. Here we'll be writing project, packages, classes, object, threads, many such things which are related to object-oriented programming. So our workspace is going to be IntelliJ for Scala. I'll be writing this line of code in this IntelliJ. Okay. Then third point, everything is object in Scala. So we can say Scala is a pure object-oriented language. Scala is a pure object-oriented language. Java is also not a pure object-oriented language. Remember, when I say pure object-oriented, which means my data member, my variable, my class, my argument, everything is object. I can treat my function as object, right? So when I call, we sometimes surprised that how can I pass a function as argument, or how can I uh, assign a function to a variable, but those things you can very well do in this Scala. It's very easy to play with the function. Fourth point, in Scala, you do not have any static concept. So Scala does not support static keyword. We do not have any static keyword here. Okay. So static means what? If you're knowing static, it's good. If not, then static means I do not want to instantiate any class again and again. I just want to prove one time. So if you want to, if you have few variables and you don't want to get the dynamic value for them, you don't want to instantiate them, you can create a static. But in Scala, we do not have a static support. I'll be taking all of this line by line, all these things in practical. Okay, so don't worry, we'll be writing these things in IntelliJ. We'll get all the points, which are point number third and fourth. So Scala does not support a static keyword. Instead, we have here, singleton object in Scala. Singleton object in Scala. So whenever you want to work with the static keyword, okay, whenever you want to work with this keyword, static keyword, it's better you can create a singleton object. Now, singleton, if I read this in English, like Oxford, so this singleton means alone. The singleton is alone. So alone object, which means there is no class, only object. Okay. So if you're thinking there is no class, then how without class object can be implemented? Because this object is an instance of the class only, right? If I go to text description, which is written in book, what they say, class is a blueprint, it's a white project, it's a thought process, and object is an instance of the class. That's what typically we read in book, in textbook. What is class and what is object when we learn this OOPS principle. Now, singleton object will be creating whenever I want to create any static concept or I want to prove anything. Okay, we'll see this. What is a static and what is a singleton object? If there is no class, only object, it's a singleton object. That's what I can explain for now. Point number fifth is if your class name and object name if your class name and object name is same, okay, let's say class A, object A, both are same, then that class is known as, that class is known as companion class. Companion class. We know companionship, somebody is giving you company, right? So companionship is what? Again, this is taken from the Oxford. Companion, uh, we can say a person, spouse can be a companion, if I talk in very layman terms, right? So we'll be using this with a different kind of modifier. Companion class will be required whenever private behavior gives you some issues. Okay, so we have very limited use case for companion, but we have one concept of companion in Scala. We'll see this also, how to create a companion class. Point number 6 is Scala does not complain you or give you any error. Scala does not complain their complain its compiler if data type is not given to variable, right? It is like just like Python, right? In Python, what we say, b is equal to 10, c is equal to 20, and b plus c, I get the answer. This is in Python. If I write the same thing in Java, I will have to write my data type name. So this, since 10 is an integer, I'll say integer b is equal to 10. And then I'll have to pass this semicolon also to terminate the statement. Similarly, if I write this in Java, let's say this is string value, we'll take two different input. This is a string value. So I'll say a string c is equal to 20. So this is what you have to explain to your compiler. You tell to your compiler that this b is an integer, this c is a string. But here in Python, I'm not saying this. This is Scala is very similar as same. So this is one good advantage I feel. If you know Scala, you know by default 80% Python. The syntax is quite common. How to create a function, um, what method we are using. Only few parentheses indentation is different in Python. So coming back to topic, Scala does not complain its compiler if data type is not given to variable. I can also ignore this in Scala. No need to write explicitly that this is integer, this is string, this is double. However, your compiler takes that, but I recommend to write them to make a code more readable and expressive. If you do not write, that's also okay, but make a habit of writing, so it will be good practice. Then 7th point, Scala function also does not require any return type. Scala function does not require any return type. What do you get by this statement? Scala function does not require any return type, which means when I create a function, I will have to define their return type. Okay, in Java, in OOPS programming, when I create a function, I'll have to say what this function is returning me. I'll have to add that in my function signature or function body. But in a Scala function does not require any return type or ask you to define the return type. one condition is there, unless the function is recursive. Unless this function is recursive. Recursive function, if you know, function calling function, that's what we call a recursion. A function can call itself as a recursion. So if it is a recursive function, then I will have to pass the return type. If it is not a recursive function, no need to pass the return type. We'll see this example when I create a function for factorial, Fibonacci. Those are series when they're calling their previous value. Factorial, if you know, what is a factorial? If I ask you the factorial of 5, you say 5 into 4 into 3 into 2 into 1, and you get the answer as 120. So this looks cool, 5, 4, 3, 2, 1, but what logic they are building? Being a programmer, I'm not focusing on the syntax much. I need to know what logic is there. This is the logic. If somebody is giving me one argument as n, so this is n into n minus 1, then n minus 2, then n minus 3, n minus n plus 1, till last I go, right? This is what, this is decreasing the value and calling it its own function. That's what we call a recursion. So there's 2 points you can remember. It does not need any return type for their function, and neither it require any variable data type. Okay, this is I think good comparison, 7-point comparison with OOPS programming and Java programming. Now next point we'll start a Scala comparison. A Scala comparison with functional programming. The Scala supports functional programming also. Okay, if you want me to name some of it, I can say Python is a functional programming. Ruby is a functional programming. Ruby on Rails. Groovy is a functional programming. This also compiled on JVM platform. Very new language. 2017, I guess 17 or 16 December. But not so many companies are working with it. Anyway, programming languages will be keep coming. You cannot learn all the languages. That's why focus on the logic, because if your logic is clear, learning syntax is just a job of 10-20 days. First point, Scala comparison with functional programming language. In any functional programming language, in any functional programming language, out of the one which I have written, by default they support. By default, they support concept of immutability. Concept of immutability. Now, what is the immutability? Immutability means you cannot change their value once it is assigned. This immutability means, let's say I'm saying A is a immutable. Okay, just for assumption, I said A is a immutable and I made this A 10. Now I want to change this 10 to 20 or any other value apart from 10. I cannot do that if it is immutable. So that way you can understand, just like a string and a string buffer. Immutable means you cannot change in simple English. Immutable means you can change. So by default, they support immutability, but Scala does not force you to choose this only. Scala gives their option, though. Scala gives choice to user, whether you want to make immutable. Scala gives choice to user. Now what choice they're giving, whether to make immutable or immutable based on the requirement. Obviously, so if somebody is asking me to calculate something with pi value, I know that this pi is never going to change. This is already proved. This is going to be 3.14 that we know, the pi value. If somebody asks me, can you tell me the pin code of one area? I know this pin code is never going to change. If somebody asks me STD code, if somebody asks me any ISD code, okay, other value which you can understand according to this real-time application, those I can make as immutable, because if I say this is the pin code of Kharadi, this is not going to change. This will be exactly same. What is it is today, what was 100 years before, what will be after 100 years. This is not going to change. So those values you can make as immutable. Pi power, there are so many functions. Now in functional programming, actually, if I give one more difference after this comparison, so there's a big difference between functional programming and object-oriented programming. In object-oriented programming, you focus on the logic, on the core concept. Functional programming is like function is already built for you in Python, Ruby, or any languages, and you can just learn to just learn to use the function. You're not creating function by yourself. You're learning how to use the ready-made function. Okay, so what do you think more important? Obviously from interview perspective or any, if you know how to build your own function, that's more important. Python will give me that option, Scala will also give me that option, but these are richer in terms of ready-made function. Nowadays Java also started supporting. I cannot uh, stand alone this concept of Java, especially from 1.8 version. Java also started supporting this functional programming, because that's the current demand. If Java will not do that, Java nobody will use. So we'll have to adopt as per industry. The current industry is talking about this too. We need both support. Function, very rich, and obviously object-oriented in concise form. Second comparison with functional programming language in Scala, functions are, and not just Scala, in any function programming language, functions are first class citizens. This has a huge meaning. First class citizens. First class citizens means uh, function can be used anywhere in the Scala. Function can, as I said, function can be passed as one value to a variable. Function can be called as an argument to a function, as in from one function I can call another function. Okay, so this function I can treat in many ways. That's the reason I'm calling these are the first class. Let me write the first. In Scala, functions are first class citizens. Right. Point number third, Scala support lazy evaluation. One of the terrific concept. Nowadays we have lazy in many places. In Hive also we have seen this concept of lazy, and I promised that time that when we visit Scala, we'll talking about this lazy. So we'll see this lazy architecture in detail. Lazy is one of the very common fundamental one of the core concept, especially with the big data, so that you can only deal with those values which are important for you, not all the values always. Then fourth point is Scala does not support the ternary operator, but I have if else condition instead of ternary operator. Ternary operator means we give this, right, this value, then maybe this value. This are the ternary operators. So we will not be using here. We will be using if else conditions or for loop condition. Scala supports all conditional expressions, all operators, whatever was possible from basic OOPS programming and functional. Everything is supported by Scala. It supports the future concept also. There's one concept of futures. Okay, futures we call, then I take all this. Then we call closures, futures, closures, Now, Scala has a framework. Okay, this is the good comparison, I think. 5 point we'll see. Scala is having a framework. Okay, so we'll be talking about now framework. And one of this framework we're going to cover. Now, two framework I'll cover actually. Play is a mobile-based application. This is for web-based application. So we don't need this web-based application here because we're not learning any web applications here. Second is your scalding. Scalding is a combination of Scala plus cascading. Scala plus cascading. Now, Scala is a language. What is a cascading? Cascading means this actually the concept has been inherited from or brought from Hibernate. And Hibernate is an advanced framework of Java. Okay, so we send this to Hibernate to perform the multiple simultaneous job. That's what is cascade. Cascade is like simultaneous, not in a sequence. That's what cascade means. I think we have used this cascade term in Hive also when we dropped a database which has many table. So we say drop database table name and cascade. Okay, multiple operations they can perform using the cascading. Now cascading is built. Web-based application is play. Scalding is built to write a job on MapReduce. Because if you're a Java programmer and I suddenly ask you to work with this Scala, then you will say this will take time. So in Java, MapReduce is definitely more supportive because the native language of MapReduce is Java. Anywhere native language has more support. You'll see the same thing in Scala also. Scalding is built on Scala cascading. They support MapReduce, but I will have to write that code in Scala, not in Java. Then point number third is the topic which will cover Spark. Spark is designed for lightning fast data processing, real time also and historical also. So Spark concept is based on in-memory modeling. They're based on in-memory concept. And I can read data from many sources in Spark, from Amazon S3, from HDFS, from local file system. And Spark has more compatibility with Scala because native language of Spark is built on Scala, not Java or any other language. This is the only reason I can say, this is the only reason that Scala is that popular today, just because of this framework. Point number fourth, you heard about Akka. Akka is also a framework, right? Looks like a South Indian name, but Akka we are using mainly for multi-threading concept. Multi-threading concept, right? Multi-threading parallel thread business. Multi-threading we call in Java. We'll be calling this framework as Akka here. Then fifth point, this everybody knows, I guess, Kafka. Kafka is also built on programming language of Scala, and this is working with MQ, messaging queuing. So to send the message from one platform to second platform. Point number six is Neo4j. Neo4j is designed for graphical database representation. This is for GraphDB. Right. We have seen this in NoSQL also, Neo4j. OrientDB is part of that. OrientDB is writing the query, but this is the display part, dashboarding part. So sixth framework, we'll see these two things. Spark I will tell you, and Akka I will tell you. Kafka anyways we're going to learn. Scalding in project, while doing the project we can see about it. So mostly I will see most of the framework, only the play, because this is like outside the course which we're doing. I'll start with the Scala immutability and mutability. Okay, so to make any, by default we say immutable, and to make any variable as immutable you'll have to use a well. Well is immutable. If you're writing anything with well, okay, well is immutable. If you're writing anything with well, you say well s is equal to Scala. You want to give one string value, then this value, this variable s is fixed for Scala. You cannot change the value of it. That's what immutable means. If you say well t is equal to, you pass any variable, let's say 203.59. This is done. You can't change because this is again immutable. Well, then what we have for mutable? For mutable, we have where. Where is mutable? As in, if you say where name is equal to Bhanu. So definitely you can change this name from Bhanu to Sanu. You can do this manipulation, data manipulation, right? Because this is mutable. So in immutable, mutable is sometimes confusing when you go forward and start remembering the previous concept. So you can understand their simple definition. Immutable means can't change, as the name itself is saying im, and here you can change it, can change. I think if you remember this 2 point, easy. Let's go and start working with some practical and to know the syntax. Okay, I'll not directly go to IntelliJ because IntelliJ is good when you know the syntax. Now, first to learn the basic syntax part, what we'll do, we'll go here. I'll tell you from where you can download this, and you can search here Scala download. Scala has got a version till 2.13, I think in 2020, but do not go with the latest version always, because some scalability, compatibility issues there, not the scalability, but compatibility issues we have in latest version. So don't download any time, anywhere, the very fine version. Always go with one version or two version less. I'll recommend you to use this 2.11.8 because whatever is there in 2.11.8 you can get that in 2.13 also. So no big difference. You have to download, you can note somewhere, you have to download this zip file in your Windows because you are using Windows machine. So clicking on this will take to download directly, and I can extract that. I can unzip this file and open my command prompt. You guys will open your, one second. You guys will open your terminal. All right. So you guys will open your terminal. Just like I'm opening my terminal, your terminal is cmd prompt, command prompt. And in command prompt, you'll have to go to that directory using cd. So I'm going to my directory where this file is present, cd downloads setup. And I'll go to my Scala folder. I'll go to my, let's run lslrt. lslrt will give you listing the file. Mine is Mac system only, Suminda. So you can see in Mac what I'm doing. CD bin. Okay. So I have to go to bin directory. This is there you will find all the script ls space lrt, and this is the script name which I will open. I can directly open here from /, but I'll recommend you go back, check your present working directory, which is at this place, then type bin/scala. So for Linux, Unix, Mac, this is the way which I'm doing. You have to open the terminal, go to that directory, take the file, submit it. For Windows, this is just a command prompt. That is the only difference. Now we'll see the basic syntax of Scala here. As I said, by default, they always create a immutable, right? Can I start doing some operation? Let me say 4 plus 9. I'll get output as 13. Now, this is like calculator. You write anything, you'll get the answer. You say 4 into 6, you get 24 as answer. By default, where they are storing whatever operation I'm doing currently, this operation is where this operation is happening. This operation is happening on RAM. Always say whenever your hard disk is not writing anything, which means this is happening in volatile space. And volatile space is a temporary space, and temporary space means the same thing, which is RAM. It does not directly go to your operating system and communicate with your hard disk, because if you ask you where this output is getting stored, where I'll have 24 and 13 in hard disk, can you show me this location where 13 and 24 is storing? There is no location in hard disk. This is a volatile space, a temporary space. Whatever I'm doing in currently this session is known as a REPL, REPL. REPL stand for read, evaluate, print, and loop. So this loop is continuously running. This is a REPL. I'll recommend this REPL, this session kind of Scala cell, to learn the syntax. Once you learn the syntax, then we can go with IntelliJ. So we'll practice 1 or 2 days here, and then afterwards we'll switch to IntelliJ. Now, a few more things. Whatever I'm doing in this session, this is only active till the session is on. Once I go from here, once I type this, you type :Q to go out from this cell. Okay. Once you type this and enter, all the operation is just gone, just wash away from the session, because this is only working till the session is active. So these are known as a session variable. This is 4 plus 9 is giving me output as 13, and this 13 has stored in a session variable called res0, because I did not define any variable for this value 4 plus 9. So machine will refer something, otherwise how machine will memorize this? To memorize this, machine needs some name, and they need this res0 name. Res0 is stored in this 13, and based checking their hash code address, this res0 must be having some address. Checking that address, I can actually access this value. Similarly, for this 24 is stored in res1. Can I do that? Can I write res0? What this will return me? If I type res0, and according to my statement, this should contain 13 as output. Enter. You'll get the same, and though it has created the same output in new variable also, which is res2. But is this immutable? Can I change this res0 from 13 to 130? As soon as I try, can you read the error? Reassignment to well. So this is saying by default, whatever I'm doing, if I'm not writing well or where, so it is internally taken well only, which is immutable, which is immutable. And since these are all immutable, you are not allowed to change their value. Once this is done for the entire scope. You cannot change it. Okay. If you want to use this, then definitely you can say this. You can say, well, x is equal to ris0 plus 4. You can do this because you're not directly changing the ris0 variable. You're creating one more variable, which is x, and then you're adding 4 plus your existing value, which is coming here as x because I have given some name, some reference name. Look, there are two things. Whatever you write for variable for identifier in all this later, A to Z or capital A to Z or mixed of any character, you type X, you type AX, anything. This is what? This is the variable defined for user. This is the variable defined for user because we people understand English. System does not understand English. System will not understand X. System will hold one address for this X, one address for this integer, which we call their memory address. So here, if you want to deep dive more into the memory management, okay, there is a JMM, Java Memory Model, and the document number 133. So if you just type Java Memory Model, you can read about this. You'll see how integer, string, float, double, date, boolean, all these are managed internally. This is mainly into the memory management, how memory is managing. So for one set of data, your memory is full. For another set of data, your memory is not full. You may get exception. So for a string, maybe it is not working. For integer, it is working. Sometimes you think, when I have memory, why it is not working? Because there is fixed cap for every data type. Okay. So X and Y, Z, anything is variable name or reference for user, and this is memory is a reference for system machine, how your machine will understand if you type X, because this X is definitely mapped with some number. This X is mapped with some number. Calling this X will take me to this number. If you want to see that, actually I can call a method. That method name is x.hashcode. So if I type hashcode, actually it is giving me directly the value. Let me take to some string. Well, s is equal to Scala. So this is a number already, that's why they're giving me number. Let me take for this value. So this is the memory address for this s. Whenever you call s, your system directly reads this from the memory. Now that depends on the internal algorithm. Is it doing sequential searching? Is it doing binary searching? Is it doing map searching? Is it doing list comparison? So what algorithm is built on? But always, whenever you work with any memory, be it Python, be it Java, be it OOPS, they refer some memory location to store these values X, Y, Z, and all. So far, I'm doing immutable, and when I'm trying to change, can I try to change this? S is not a Scala. Actually, this is Spark. Again, it throws me the same exception. Reassignment to well is not allowed because I'm trying to reassign new value to this S. And however, I made this S using well, which is a value. Then can we make some mutable? And by the way, one thing I'll tell you, you can write well S is equal to Scala also, and you can write Spark also now. If you're thinking now I can change it, why earlier I was not able to change it? Both are different statement. First line, s is equal to spark. This line is not this line is not what I can say. This is a reassignment, and this is a redeclaration. Yeah, I can use a term here, redeclaration. So here I'm redeclaring this S, right? I'm calling this well S, which means I'm redeclaring this S is equal to spark, and I can write anything. The redeclaration will work because I'm overriding. This is like you're overriding the previous value, right? But if it is immutable, mutable overriding will work in both the cases. S is equal to spark when I just try to do. Here I'm not trying to redeclare. I'm trying to reassign the value, which means earlier was a Scala and now I want to change this to Spark. So there's a difference, big difference in fact, between reassignment and redeclaration. So do not confuse between these two terms. Reassignment means changing the existing one. Redeclaration means again declaring using the well or well to any other value. I can make this S, by the way, not string only. I can change this to anything. I can change this to integer, to double, to float, to boolean, to date all possible value. Okay. However, I'll not recommend you to write this also. My recommendation is with good code and easy code. You should actually define this string here. Scala is not complaining you, but if I'm a new user who is joining your project and you have already written 100 lines of code, if I'm going through that code, I'm unable to understand what you have written, then I'll be keep pinging you that please explain me what is this. So if you pass a comment or if you write like this, anybody can understand, okay, this is a string, a non-business user also. So this is my recommendation. Both will work for you. I'll be using sometime this maybe based on the requirement, sometime this. But for code readability purpose, I think this is good. All right. Now can we see some example for mutable where what can change? A phone number can change. So I'll give well where integer is equal to 889210090. I'm taking some 1 2 3 4 5 random value. Integer number too large, okay. Still large, now fine. 5 plus 4, yeah. This takes till 9 actually. So there is a range for all the data type, integer, long. However, you can deal with this also, but I'll have to change this from integer to long in that case. Integer value is this. I'm really sorry, I made the name itself as integer. Let me call this as I and integer. And one more thing, yeah. Your data type is always the first letter is capital here. Okay, if you're checking the data type which I'm defining, the first letter should always be capital. If you give small, you'll get error. So data type should always be capital. Be capital in Scala. For function, for variable, for anywhere, always be capital. Okay. Now I want to change this I value from 8892.1000.9 to 8. Okay. This is why working, because this is mutable. This is where. So your whole journey will start from well and where, and it will end up here only using this mutable and immutable concept. Now, if you type I, what you will get? You'll get 9 or 8. Obviously, the previous one. And it is telling me also that this is integer and this is the value. So when I can change the value, this is mutable. When I cannot change the value, it is immutable. No need to type the data type for any variable. But if you feel it will give me good understanding, you can write it, no issues. After this 2 point, okay, we will see some block expressions, some ternary operations, some if-else conditions, some for loop condition. There are so many while loop conditions. So conditional expressions we'll see widely. We'll see all these points on Thursday. So one book I'll share with you, one cookbook. I think all the file I shared. So check if that book is with you. Scala cookbook. If not, I will share. So just drop me a mail. If it is not having with you, I'll reshare again. So see you on Thursday. Start going with some basic concept now, because this is the programming language. Whatever we have seen so far is just a tool. So we learn how to work with the tool. Here you're not learning the tool, you're actually trying to build a tool using these languages. We'll continue on Thursday.